So good morning, welcome back to the next class of chapter number 2, process management. So today going to discuss about process scheduling and job scheduling. The process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and the selection of another process on the basis of particular strategy. Process scheduling is an essential part of a multi-programming operating system. Such operating system allow more than one process to be loaded into executable memory at a time, and the loaded process shares the CPU using time multiplexing. So what is the reason for this scheduling? Because scheduling is required when number of processes enter into a system, but a system having one process having one memory. So definitely there is a scheduler is required to scheduling the all process or all the jobs wherein those are entered into the system. That means all the process will be processed, but that should be scheduled. Similarly, an example is there. Suppose there is one classroom and one batch student is there, and there are number of 5 subjects is there, and that means 5 faculties must be teach that students, but classroom is one. So definitely there is a scheduling is required. Right now, all that faculties member follow that scheduling and enter into the classroom one by one and complete that talk. Right now. So similarly, when there are a number of the process enter into a system and the system having a single process, so definitely there is a scheduling concept is required, and that scheduling is done by a scheduler. Right. So that means the process as scheduling means there is another number of queues. The operating system maintains all PCBs in process scheduling queues. The operating system maintains a separate queue for each of the process state, and PCB of all process in the same execution state are placed in the same queue. When the state of process is changed, its PCB is unlinked from its current queue and moved to its new state queue. Right? That means when a process present in the new state, PCB is present in that state. When the process switch over in the ready state, automatically the PCB delink that previous link and join to the next state where the process is being there. Right now. So the operating system maintains the following important process scheduling queues. One is your job queue, second is your ready queue, third one is your device queues. Job queue is that this queue keeps all the process in the system. Ready queue, this queue keeps a set of all process residing in main memory, ready and waiting to execute. A new process is always put in this queue. Next is your device queues. The process which are blocked due to unavailability of an I/O device constitute this queue. So come to the scheduler part. What are the schedulers? Schedulers are special system software which is handle process scheduling in various ways. Their main task is to select the jobs to be submitted into the system and to decide which process to run. Scheduler have 3 types: long-term scheduler, short-term scheduler, and the medium-term scheduler. So first come to the scheduler means what? Which is the scheduling the jobs. Next is the 3 type: long-term, short-term, and medium-term scheduler. So first come to the long-term scheduler. It is also called a job scheduler. A long-term scheduler determines which programs are admitted to the system for processing, and it selects process from the queue and loads them into the memory for execution. process loads into the memory for CPU scheduling. Here the primary objective of the job scheduler is to provide a balanced mix of jobs such as input-output bound and processor bound. It also controls the degree of multiprogramming. If the degree of multiprogramming is stable, what is the degree of multiprogramming? Degree of multiprogramming means number of process. Degree means number of process enter into the computer system. It is known as the degree of multiprogramming. If the degree of multiprogramming is stable, then the average rate of process creation must be equal to the average departure rate of process leaving the system. On some system, the long-term scheduler may not be available or minimal. Time-sharing operating system have no long-term scheduler. When a process changes the state from new to ready, then there is use of long-term scheduler. That means up to new state or ready state, that the long-term scheduler is working. Next, what about the short-term scheduler? It is also called the CPU scheduler. Its main objective is to increase system performance in accordance with the chosen set of criteria. It is the change of ready state to the running state of the process. CPU scheduler selects a process among the processes that are ready to execute and allocates CPU to one of them. Short-term scheduler, also known as dispatcher, basically it is working within the processor. That means it is the scheduling the job, when it is scheduling the job from the ready state to the executing state. But up to the new state, that is a long-term scheduler. But when the process actually admitted in the processor area, right now, in that case, the short-term scheduler is working. It helps to switching the one state to another state. It helps to the, you can say the scenario like when a process in the running state, it moves to the waiting stage. That type of scenarios is followed by the short-term scheduler. Next, come to the medium-term scheduler. Medium-term scheduler is part of the swapping process, what we discussed in the chapter number, I think, 3. It removes the process from the memory. It reduces the degree of multiprogramming. So, the medium-term scheduler is in charge of handling the swapped out process. A running process may become suspended if it makes an IO request, and a suspend process cannot make any progress towards completion. In this condition, to remove the process from memory and make space for other process, the suspended process is moved to the secondary storage, and this process is called swapping. And the process is said to be swapped out or roll out. Swapping may be necessary to improve the process mix. So, there are 3 types of scheduler: long-term scheduler, short-term scheduler, medium-term scheduler. Long-term scheduler is that scheduler which is known as also job scheduler, and it determines which programs or which process are admitted to the system. But short-term scheduler, it is working within the processor area. It is used to switching the system from one state to another state, like ready to new to ready to running to waiting to again ready to running to execution. So these are all things is controlled by the short-term scheduler. And special the mid-term scheduler is working for the swapping process, right? Where it removes the process from the memory and reduces the degree of multi-programming. So, for today's class, this much. For next class, we are going to discuss about the context switch. Thank you to all. Thank you.